Hello everyone. This is a continue of chapter 5 about describing data by using numerical methods. In the previous lecture we talked about how to describe one numerical variable. But starting from now we are going to learn how to describe the relation between two numerical variables. One of the methods to draw this relation called linear regression between two variables. In this part we will learn the coefficients that measure strength of a linear relation between two numerical variables, the equation of line that represent the relation between two numerical variables. First coefficient that represent the relation between two numerical variables called sample covariance. The covariance measures the strength of linear relation between two variables calculated using this formula, where covariance xy represent the measure which we want to talk about, sxy same thing, and as you see we have a fraction. In the numerator we have a sum starting from 1 to n, where n represents the number of couples of variables. And here, as you see, we subtract from each value x, we sign it as xi, minus mean of x variable, multiplied to yi, which represent the variable y with number I, minus average of these variables. If we find all this multiplication where I start from 1 to n, multiply them and then add up all this multiplication and then divide the result by n minus 1, we will obtain covariance between two numerical variables. And if as a result of covariance we will obtain, if we obtain something positive, we say that x and y tend to move in the same direction. If covariance less than 0, we say that x and y tend to move in opposite direction. And if covariance equal to 0, we say that x and y are independent. What does it mean x and y tend to move in the same direction? It means that if one of the variables increases, then the another variable also increases. Here, if one of them increases, another one decreases. But here, covariance, if it's equal to 0, it means that we cannot find out the relation between x and y because they are independent variables. Now let's talk about the next coefficient called coefficient of correlation. Measures the relative strength, okay, not just strength, relative strength of the linear relationship between two numerical variables, calculated using this formula, where r, as r, we sign the sample coefficient of correlation as a fraction. In numerator we write covariance of xy, which we calculate using the previous formula, and in denominator standard deviation of x variable multiplied to standard variation of y variable. Now let's consider the properties of coefficient of correlation. The first thing is that it's unit free, ranges between -1 and 1, close to -1, then we say the stronger negative linear relationship, closer to 1, the stronger the positive linear relationship, and if it's equal to 0, we say that it's a weak linear relationship. Okay, the values ranges of it is between -1 and 1 because its properties, because its formula. Unit free means that, for example, the length you measure by centimeter, the weight you measure by kilograms, but it's unit free. There is no any unit for this measure. And also, if it's -1, close to -1, it's strong negative linear relationship, and if it's close to 1, strong positive linear relationship. Okay, exactly linear relationship, because it measures the linear relationship. Now consider the scatter plot with various correlation coefficients. It means that in xy plane we will put the points given in the data and show what is the relationship between the structure of the points and the value of the correlation coefficient. Look at first. Suppose that your variables x and y, you put the x variables on the horizontal axis and y variables on the vertical axis. Suppose that this is the first point. For this point you have two values, x1, y1, x2, y2, x3, y3, and so on. And especially for this case, all points for the couple xy located on the one line, and the direction of lines decreases. Therefore, it's perfect negative linear relationship. Okay, perfect, because all the points on the one straight line, and it decreases. Because when you increase the values of x, automatically y values decreases. This is not perfect negative linear, it's strong negative linear relationship. Why negative? Because you obtain the coefficient of correlation as a negative number, and the points close to this line, but not on this line, but it's very close. Okay, so therefore it's stronger negative linear relationship. Let's go to this case. Here we have the opposite of this case, all points on the straight line, and when x increases, y increases also, and the points on the one line, one straight line. Therefore this is perfect positive linear relationship. This is positive linear relationship, but it's weak because it's less than 0.5. Okay, it's not written in the lecture, but if the coefficient of correlation between 0.5 also included, and negative 0.5, we call them weak linear relationship. Therefore this case we call weak because it's less than 0.5, positive because it's increases, weak positive linear relationship. For these two cases, the correlation coefficient not determine the points on a straight line or not, just it's represent that the value r equal to 0, that there is no any linear relationship between the variables x and y. Okay, if x increases, y remains constant. In this case, x increases, y decreases, increases, and general situation is that when x increases, y not change it. Okay, but in this case, especially in this case, the value of correlation coefficient cannot determine that the points lie on one line or not. But for the positive and negative linear relationship, you can understand it by finding the value of correlation coefficient. Okay. Next measure called coefficient of determination, which also one of the measures that describe the relation between two numerical variables. And It's calculated using the it's calculated by finding the square of coefficient of correlation, the coefficient of determination, sign it as r squared, calculated using this formula. Okay, r squared, together this thing we call coefficient of determination. Now we are going to interesting thing. This is the explanation why we calculate coefficient of determination and why it's very important in statistics. The coefficient of determination is the portion, or you may write there percentage, is the portion of total variation in dependent variable y, okay, that is explained the variation in independent variable. Dependent variable, as always, as a dependent variable we mean y, and independent variable x. Okay, this coefficient represent the percentage of points which can be explained by the linear relation equation of linear relation. Okay, after this slide we are going to find out the formula which will calculate for us the linear relationship. And before finding linear relationship, you can find out what percentage of your points can be explained using this formula. Because correlation coefficient are between minus and 1, coefficient of determination will be between 0 and 1. Now let's show the relation between scatter plot, the graph of points, and coefficient of determination. Look at the first graph. This is perfect linear relationship, negative linear relationship. All points lie on one line, where the points we see in the descending form. When the values of x increases, y decreases. For this case, r squared, which also represent the coefficient of determination, equal to 1. Here, coefficient of determination also 1, and this is strong, not strong, this is perfect positive linear relationship. Perfect linear relationship between x and y shown in this graph. It means that when during the calculation of r squared, coefficient of determination, if we obtain the result 1, we can say that all points lie on one line, or all of the points can be explained by the formula of linear relationship, or all points. Instead of all points, you may say the portion. What portion? 100% of the points follow the equation of linear relationship. Yes, 100% of variation in y is explained by variation in x. For this case, for example, coefficient of determination between 0 and 1, weak linear relation between x and y, because the points, as you see, far away from being on the straight line. That's why this is weak linear relationship between x and y. And what does it mean? It means that some, but not all, the variation in y is explained by variation in x. After introducing you the coefficients which help us to understand the strength of a relationship, linear relationship, we can talk about regression analysis. Regression analysis is used to predict the value of dependent variable based on the value of at least one independent variable. Explain the impact of changes in an independent variable on the dependent variable. And as we talked about previously, dependent variable is the variable which we wish to explain. It means y. As always, we take it as y. An independent variable is used to explain the dependent variable. As always, in math, we take it as x. Now let's introduce you a linear regression model. The relation between x and y is described by a linear function yi equal to beta 0, this is first coefficient, plus beta 1, second coefficient, xi, plus epsilon I, where beta 0 and beta 1 are the model coefficients and epsilon I is a random error. Let's show what this coefficients means. Suppose that this is the points given in your data. This is x1, x2, x3, x4, x5, x6, and so on. Let's say, as a generalist talking, let's say this is xi, okay? And suppose that this is the line which pass through these points, and the line which we want to find out, okay? But right now you cannot understand how we calculate the formula of this line, okay? As you see, some points very close to line. It's possible that some points exactly lie on this line and some points far away from this line, okay? What is epsilon I? Epsilon I represents the vertical distance from the point to that line, okay? Beta 1 represent the slope of this line which pass through these points, and beta 0 represent the y-intercept. It means the point of intersection of this line with y-axis. Beta 0 represent the y-intercept of this line with y-axis, okay? Epsilon I is the vertical distance from the point to this line. Here it's negative and close to 0. Here it's negative. Here it's positive, close to 0. Here also close to 0, very close to 0. Here is negative, and so on. How we determine slope and y-intercept of the line which pass through that points? Coefficient beta 0, b0 and b1 are obtained by minimizing the sum of the squared differezeness between the observed and predicted values of y. Okay, b0 and b1 obtained by minimizing the sum of squared differences. It means that you find the difference and then find the square between observed and predicted values of y. What is predicted? Predicted values, the points which lie on line, this line, and observed is the points itself. Okay, the difference between predicted and observed value is this distance. We sign it as epsilon I, and the square of it is epsilon I squared. Here the distance squared, here distance squared, distance squared, distance squared, distance squared. If we find all the sum of these squares, okay, and then if we can find the line which make this sum minimum, then this line we call the regression line, okay? And for this case we use differential calculus is used to obtain the coefficients b0 and b1 that minimize the sum of square errors, okay? This thing we call errors here. Now let's find out B0 and B1 for least squares equation. Okay, why this equation also called least squares equation? Because as you see in the previous slide, we talk about the line which make sum of square errors minimum. Therefore, it's called least squares equation. Sometimes we call it regression line. Okay, both of them is acceptable and use it in statistics. The slope coefficient calculated using this formula. B1 equal to fraction in numerator covariance xy and in denominator sx squared multiplied and also it's equal to r multiplied to sy over sx. Both these formulas correct. You may use this one or this one, doesn't matter, it's up to you. And y-intercept B0 calculated using this formula. B0 equal to y bar, the average of variable y, minus B1, which we obtained from here, multiplied to x bar, average of x. And this coefficient B0 actually we find out because we should know that the least squares line pass through x average of x and average of y, pass through the point x bar y bar. Okay, from this point, yes, the regression line always goes through x y bar. Very important thing is to interpret the slope and y-intercept. The coefficient B0 estimate the average value of y when the value of x is 0. If x0 is in the range of observed x values, and the coefficient B1 estimate the change in the average value of y as a result of 1 unit change in x. Very important. Two coefficients. B0, the value of y when x equal to 0, in simply saying, and B1 represent if we change x 1 unit, the change of y. Okay. Okay, the coefficients B0 and B1 and other regression result in practice should be found using a computer. Besides finding the result by hand, help us to understand the meaning, the formulas. In this lecture and for homework questions for now, we will calculate everything by hand. But for the next lecture, we will try to explain you how to calculate these coefficients by using LibreOffice calculator program. Let's consider the example. For the data 1, 2, 2, 3, 3, 5, 4, 6, find equation of linear regression line, coefficient of determination, and interpret their meaning. You should know that this couple, 1 represent x, 2 represent y, x, y, x, y, x, y. Independent variable, dependent variable, independent, dependent, independent, dependent. Okay. For this question, we are going to use table method, but it's up to you. If you want, you may directly use your calculator for calculations. Also, you may use the table method. In table method, we put the points as a column. X values we wrote here, 1, 2, 3, 4. Okay, 1, 2, 3, 4. And correspondingly y values, 2, 3, 5, 6. For the formulas of standard deviation of x values, we need x minus x mean squared. We need y minus y mean squared. For covariance, we need these multiplications, x minus x mean, y minus y mean. After filling this part, we can easily calculate x mean, which is sum of these values divided by number of values. Y mean, same thing. N minus 1, here, because we have 4 couples, n minus 1 equal to 3. Covariance. To find the covariance, we will divide this sum by n minus 1 because it's a formula for covariance. For Sx, we find the square root of this sum divided by n minus 1. Similar thing for Sy. R equal to covariance divided by Sx multiplied to Sy. R we calculate using this formula. And for Y, we use the formula for B0 and B1. Let's now show you how we calculate it using the table. For solution, we will use these formulas. As you see, this is the formula for calculating the average of x and y. This is the formula for calculating standard deviation of x variable and y variable. Formula for sample covariance. Formula for correlation coefficient. Formula for coefficient of determination. This is slope of a line. You have two formulas. You may use both of them. Y-intercept. And finally the value, and finally the equation of linear relationship. Okay, now let's see how we calculate it. First, we add up all the values of x. 4, 3, 2, 1. It's 7, 10, yes? 10 divided by 4, it's equal to 2.5. That's why x mean is 2.5. Y values, if you add up this thing, 2, 3, 5, 6, it's 16, sum of them, divided by 4, because number of values is 4, gives you 4. Therefore, y mean is 4. X minus x mean. From this value, 1, you subtract 2.5. What gives you? 1 minus 2.5. It's minus 1.5. The square of this thing is 2.25. Okay. For the next variable value, from 2 you subtract again 2.5. It gives you 0.5 with negative sign, of course. And negative 0.5 squared gives you 0.25. 3 minus 2.5. Again 0.5, it gives us 0.5 squared equal to 0.25. 4 minus 2.5, 1.5 give us, and the square of 1.5 is 2.25. Similar thing we will do for this part. We will use just instead of x the values of y, and instead of x mean we will use y mean. Let's consider some of them. 2 minus 4 is negative 2. Negative 2 squared, 4. 3 minus 4 minus 1. Minus 1 squared is 1. 5 minus 4, 1 again. 6 minus 4, 2. 2 squared is 4. The next step, we should find the sum of this thing. Sum of this is 5. Sum of these numbers is 10. In order to find the standard deviation, we just divide this number by n minus 1, which is 3, because couple of numbers here 4 and n minus 1 is 3. We divide 5 by 3 and find the square root of it, we obtain 1.29 for standard deviation of x variable. For standard deviation of variable y, we must divide 10 by 3 and find the square root. It gives us 1.83. The next thing is finding the covariance. As you know, in the formula of covariance, we have x minus x mean multiplied to y minus y mean and sum of these multiplications. Therefore, we just need to subtract from 1 this 2.5, which gives us negative 1.5. From 2, we should subtract 4, which gives us negative 2, and then multiply these two differences. It gives us 3. Similar thing here. 2 minus 2.5 minus 0.5. 3 minus 4 is minus 1. If you multiply these two things, you will obtain 0.5. Similar way, we obtain this, and then we add up them. It gives us 7. And then 7 divided by 3 gives us value for covariance, 2.33. By knowing covariance, standard deviation of x and standard deviation of y, we may find correlation coefficient. Correlation coefficient equal to covariance over Sx multiplied to Sy. And it gives us 0.98. Next coefficient is coefficient of determination, which we need to find. Coefficient of correlation equal to square of coefficient of determination equal to square of coefficient of correlation. If you find the square of this number, you will obtain approximately 0.98. What does it mean? It means that the least squarest regression line, explain 98% of the given data. 98% of our given data follow this line. Okay, all these points follow this line. Therefore, it's interesting. It's very close to 1. It's very close to perfect linear relationship. Therefore, it's interesting to find the relation between these two variables. That is why we need B1. B1 is R multiplied to Sx over Sy, which is give us 1.4, and B0, the formula where we'll use x mean, y mean, and B1 itself, give us 0.5. Therefore, the formula is this, which represents the relation between these two numerical variables. And you can check also this formula. For example, when you put instead of x1, it's give us 1.4 here. 1.4 plus 0.5 is 1.9, very close to 2. If you put instead of x2, it's 2.8. 2.8 plus 0.5, 3.3, also close to this. If you put 3 here, it will be close to 4. If you put here 4, it's equal to 6.5, 6.1. As you see, this line shows the linear relationship between these two variables. There is also other type of relationship. In this semester, we talk only about the linear relationship. And it's interesting to find the linear relationship when coefficient of determination close to 1. If it's very close to 0, it's useless to find out the equation of this line. But if it's close to 1, it's interesting because it's approximately give us the same result when we plug instead of x these values. Okay. Also, why it's important to find out this relation, because you have only these values, yes, 1 2 3 4 values, and their corresponding y values. But it's also interesting, what is the value of y when x equal to 3.5? It's a prediction. Just by using this number you cannot find out it, but by using this equation you can find out. Just plug in here 3.5 and get the result for y, approximate result of y. Also, you may predict the numbers which is not in the domain. For example, you may put here 5 instead of x and find out the result for y. If you put here 5, you will obtain 7, and the result will be 7.5. For value of x, the value of y approximately equal to 0.5. That's all. That's all for this topic. I hope that you may solve the homework questions after understanding all these things. Thank you very much for using it. Goodbye.